yesterday we left off on slide number 12 is where we finished. We've been talking about ways to classify, ways to group, and the first way is to look at those physical type properties. So physical properties include a lot of things that are kind of very obvious and basic by using your senses. How does it smell? How does it feel? What does it look like? Obviously, we use our sight for a lot of things, but kind of specifically, if you're thinking of trying to determine, where something needs to belong or how to group it, it makes sense that you're going to be using a lot of your senses, right? Probably, not in science, but in real life, obviously, you would even use taste a lot to categorize. Is it sour? Is it sweet? Is it spicy? Is it salty? That kind of thing. So we had left off with some of these are, things that we've already had, topics, density, magnetism, and so any type of physical property that you're using is dealing with something that does not change the object that you're dealing with, right? So when you're talking about a physical property or a physical type of change that something could undergo, you're not changing what you're dealing with. You're only changing maybe the size, the shape, possibly the color. Like if you paint it, or if I put fingernail polish on, right? I didn't change what my nail is, I just changed the color of it, right? So if I have a wall and I paint the wall, it's still a wall, it just has a new color to it, right? So I think the physical changes are pretty easy, all right? We're gonna move on and look at chemical changes. Okay, and so remember, when we're talking chemical changes, we're talking about something that changes the bonds, it changes the arrangement of protons or electrons. So we're dealing with something that is no longer the same as it was originally. So it's any characteristic of a substance that is observed during a reaction where the chemical composition or identity is permanently changed, meaning you can't go back. You can't return that egg that is fried to the raw egg. There's nothing you can do that can make that happen, right? If you have a firework and you explode the firework, that's a chemical change. You can't unexplode it and put it back into like the tube or the container or however, it came, okay? So sometimes you just have to think, okay, can I make it go back? If the question is no, then you're probably dealing with a chemical change, right? A few of these are kind of hard to distinguish between. So like if you dye your hair, well, you're like, oh, well, that's like permanent hair color. Well, it's changing the current hair, but like your hair, itself is not going to grow from your roots the new color that you have it dyed, right? So there are a few that it's like, is that a physical change? Is that a chemical change? Like, there are a few that I get that are a little bit hard to kind of figure out that way. So I try to stay away from some of those trickier ones, like on assignments or tests or things like that, because I get like, you can kind of make an argument either way, and I'm not trying to trick you. So the ones that I will actually ask you about are kind of more, the more obvious ones, right? But if you can ask yourself, did I change what it is? And your answer is yes, then it's probably a chemical change that it underwent. So in a chemical change, the original substance has a new chemical composition and it is not the same substance that it was before the change occurred. And there's a few things that are like absolutes. Anytime you bake or cook something, it is no longer the same stuff, right? Any type of baking or cooking, any type of burning. Once you burn something, you can't unburn it. And you're like, well, when I burn toast, I just scrape off the burnt part. Well, sure, but it's still like you're removing that, but it's not that you changed it back into the original toast, all right? If I have a piece of paper, I can't unburn it once I've burnt it, right? So just kind of think about that. Even when, and this is from 8th grade last year as well, like we referred back to a few things yesterday, the iron that mixes with oxygen to form iron oxide, that turns into rust. That's what rust is, iron oxide. You can sand it or sandblast it or, try to rub that rust off and you can get rid of the rust, but you're not turning the rust back into iron, right? It can't go backwards. You can't go from iron oxide just into iron. So you can remove the rust, you can clean it up. The same thing with patina. If you have that oxidation on copper, you get that green kind of film or that green layer, you can clean that, right? There's lots of cleaners for copper. You can wash it off and you go back to copper. But you didn't turn the patina back into copper. You just removed it to make the copper that was still there existing, more clear to see, right? So sometimes you might get, it's a little confusing because you're like, well, I can make it go away. You can, but you're not like turning it back into what it was originally, right? So that copper that turned into patina is now forever gone. It's forever into that patina or washed away when you clean it. Same thing with the rust. I can, sand it and get the rust to go away, but I can't turn that rust back into the iron, okay? And so, again, think back to the chemical weathering that we talked about in 8th grade, right? My example yesterday, and Haven, you'll have to watch the video notes so you understand what this example is I'm going to give you, but remember the broken cookie was my physical change. My puked up cookie was the chemical change, okay? All right, and we will come back to these videos in a minute. Okay, so there's something called chemical reactivity. Thank you. So this is the ease with which a chemical compound tends to react when it comes in contact with other compounds. Now we mentioned this yesterday. What we've talked about so far is those valence electrons. That's kind of simplistic. Once you get into chemistry, there's some other things that will determine what will react and how it will react. But right now, the main thing is that we know it has to do with those valence electrons. If they are close to having their valence level full, whether they could gain or lose a couple, they're going to be very reactive. Okay. So when you have something that has high reactivity, that means it's going to react quickly and easily. And then obviously it kind of makes sense that the reverse would be true. Low reactivity, if it's going to react slowly and not very easily. So, like our noble gases that just sit there on their donkeys would most definitely fit into the low reactivity. And then high reactivity would be like our alkali, our alkaline, and our halogens. Okay, this is a really good little slide. I think that you have, you're going to fill in, there's like a little white box here and here. So you're going to put chemical change, physical change. So here's a way that you can kind of always tell, or not always, but it's kind of a little quick cheat to see if something would be a physical change or a chemical change. So typically if a gas is formed, so like when you do like the most common little demonstration of baking soda and vinegar and you combine them to like make the volcano eruption, when that gas starts bubbling out, that's a really good indication that a chemical reaction has taken place or is taking place, okay? So the formation of a gas. A lot of times if heat is produced, so the little hand warmer packets, they don't do anything until you twist them, right? And so once you twist them, what you're doing is you're actually combining a couple different chemicals in that packet so that they start to mix together. Once they're mixing together, they start forming that chemical reaction. One of the byproducts of that is heat. That's why you buy that little packet, so you can have that little hand warmer and put it, in your pocket, or sometimes people put them in their shoes or boots or whatever. And so it gives you're buying it because you want that heat source, right? And so by starting that chemical reaction by, combining the materials in that twisting process, the chemical reaction starts to happen and it gets hot. It doesn't go on forever. Sometimes they last, like an hour or two, some of them maybe a little bit longer. But the whole time that the chemical reaction is taking place, heat is going to be given off, right? So it's an exothermic reaction. And so you are able to benefit from that, but it's not something that's going to last forever, right? Or else they'd probably be out of business because once you buy one, you never have to buy another one. right? But it will eventually stop. Once the chemical reaction stops, then the heat that's given off during that reaction stops as well. So a lot of times, and the same kind of thing with like those glow sticks or glow necklaces that are popular like at concerts and parades and like at the fireworks shows and stuff like that. If you shake them, or sometimes you even give those a twist, you're combining the chemicals in there again, and light is produced. That's just a natural byproduct. So a lot of times these are kind of indications that a chemical change is happening. We'll talk about the formation of precipitate when we get to solutions. Color change. Now, this is a tricky one because I just gave you two examples of physical changes involving color. Painting my fingernails or like painting the walls or something, right? That is a color change also. When we say color change over here, what we're talking about is like a chameleon changing color, leaves in the fall changing color. You know, those kind of things, which are a chemical-based change. And so we'll look at some more examples, but color isn't an automatic, always physical, and it's not an automatic, always going to be representing a chemical type of change. So you have to be a little bit careful when you get to color, all right? And then it just gives examples. Anytime you have baking or cooking, right? Food digestion, rotting fruit, rotting like dead animals, right? Rotting logs, anything that is dealing with decomposing is going to automatically be a chemical change. So you might want to put like a star by rotting and a star by baking, because those are going to always be chemical, right? You might also want to write, if you have space like off to the side or something, or even here, burning, that is always a chemical as well, right? So let me write these up here. Burning, and for me, my family would say that's how I cook. So burning, cooking, rotting, right? Those things are always dealing with chemical. Always chemical. No question about it. Okay. And then if we go over here to our physical change, tearing, right? Cutting, folding things, all of those are dealing with changing their size or shape. Painting them. So again, there's color change, right? But this is just putting a color over top of the existing item. The existing item, whether it's my nail, whether it's the wall, you know, whether it's the board with the blue and green, you know, ink on it, right? It's still the board. It's just I put color over top of it. So if you're just putting color over top of it, then it's just considered a physical change. Leaves changing color, those aren't spray painted, right? They are changing color internally, and so that's a chemical change. Now, melting, freezing, and boiling. All three of those are phase changes. So the big thing with something that is always going to be a physical is, or are our phase changes. Phase changes. And that means like going from a solid to a liquid and then to a gas, or a gas to a liquid to a solid. Okay? So phase changes are always physical. And that's, so anytime it's talking about melting, freezing, boiling, condensing, evaporating, all of those physical changes. Think of water. If I have a cup of water, I can boil it and make it turn into steam, or I can take that liquid water and I can freeze it, making it into a solid. It is still water, right? No matter what I do to it, it's still the same water. It's still H2O, right? So it hasn't changed. It looks really different. Like steam looks really different than an ice cube. I get it. It looks different, but what it's made up of chemically hasn't changed. So that's why it's just a physical change. Dissolving. Sometimes this gets people a little bit confused too, and I'm going to prove. I have a demonstration that we'll do sometime this week when it fits in good. What I do is I take like a packet of Crystal Light, or basically like Kool-Aid, and I put it in water, mix it up, right? It looks like the Kool-Aid or the Crystal Light disappears. So it looks like it now becomes part of that liquid, right? So it looks like you have something totally 100% different. You had plain water, you have the Crystal Light, you put them together and it looks like you get something brand new. I'm going to prove to you that it's a physical change because we are going to boil that Kool-Aid or Crystal Light and then we'll see what happens, okay? And we'll leave it at that for now, but I will prove to you that dissolving things is a physical change, that both items are still there, they just haven't, they kind of combined into a new solution. And so we'll get to that when we get to our mixtures and solutions a little bit more. Okay. So again, you get something new and it can't be reversed. You keep the same thing and you haven't changed what it actually is. Okay, so let's take a look at this. What do you think? For tearing paper, is that going to be a physical change or a chemical change? Physical? Absolutely, right? Physical. So what if I boil water? I'm going from a liquid now to a gas. It's always going to be what type? Physical. And I saw some eyes looking at the board. That's great. All right, so making Kool-Aid, and again, this is kind of a tricky one, or making that Crystal Light. This is dissolving powder into the liquid. It's going to be a physical. Very good. And then, you guys must be asleep. Usually people are like, ew, yeah, why you put something nasty like that? Well, nasty stuff helps you remember things. Let's just face it. So, what is that going to be? Physical or chemical?
Chemical.
There's a good bad face. That makes me good. Feel good that at least you're awake. Chemical. No matter how much you brush, that poor guy, mustache, that poor guy is not going to get those teeth back. Usually someone's like, well, he could get dentures. Well, sure, probably going to need them. But that's not his teeth, right? They're not turning those teeth back into normal, healthy teeth, okay? So definitely that is going to be an issue. Ugh. Cannot make them go back. Okay.